it here or is it in another channel?
I'm not sure which voice channel. Sometimes it's cafe, but I think it is in yeah, one of these two, cafe or I think it's usually in cafe actually.
Okay.
I'm still new to OneHive, so I'm not sure.
This is the first meeting I come to Luna Swarm too.
Mm. Hey Jeff,
Hello, Jeff.
Hey guys, how's it going?
Well,
pretty good.
uh,
Tired.
do you used to come to Luna Swarm, Jeff?
Sorry, do I usually come to Lunaswarm?
Yeah.
Oh yeah, I'm here every call.
Cool. Hello,
Hey Z.
Michael. I was saying that this is one of the first times I come. I think that I came to the first one only.
Is it the church bells, Sam?
Yeah. It's time to begin.
Yeah.
It's the
Nice.
council.
Signs. Hey guys, I'm here. I'm gonna have to be mostly muted because I'm in a car, but I'm pretty sure we have a solid agenda anyway. So as people kind of fill in, I think Jeff can probably kick it off, and that Sean and others have stuff to present. So I'll probably just stay muted unless you need me.
Like I'm trying to zoom out and look with
Yep, that sounds great. I've got agenda here, and I believe we have a few people joining this week, like Andrew Clark. So yeah, we should have lots to talk about, and happy to have you weigh in as you can see. We can give it a few more minutes until yeah, Luke and a few other people show up before we kick it off.
You can try pinging Andrew in Slack just in case he. I don't think he's been in this Discord before. Maybe he has. I guess maybe he has. But it's a little tricky because I think to get to this channel, you need to do something to be able to see it.
I will generate a link and send it over to him just in case.
Hello, friends.
Hey Luke.
Hello, Luke.
Hey, hey.
Yeah, Marco just kind of put some stuff there. So now I'm just introduce yourself, share.
All right, cool. So I shared the Discord link with Andrew Clark, who may be able to join us. I believe he confirmed on the calendar, so maybe he just is running late from a previous call. So we may expect to see him. But in the meantime, I think we can probably kick off discussing the agenda. So we've got a few guests here this week who are invited to present on various aspects of bringing in the live data from the conviction voting model and how we can, or sorry, from the live deployment and how we can feed that into the model and do all sorts of neat counterfactual analysis and so on. So Andrew, when he comes, can go over the existing conviction voting model and establish where to plug in that agent behavior. Sem, I think we discussed using the data sources such as the graph or other tools and how they can be used to port in that live data into these models. And Sean, definitely one of the experts on GraphQL data, bringing in live data and how that can be used for Honey model visualization. So are there any other prominent agenda topics, or I am happy to turn it over to some of these subject matter experts and let them run the show?
I was just going to ask if you could record. I've got a feeling that this is one that I'd want to go back and reference.
Yeah, I'm recording.
Definitely.
Perfect.
Cool. So to start off, Luke, maybe you can start off and we can kind of jump into some of the kind of areas of expertise here as they come up in kind of the context of the current model. Or would you prefer Sem or Sean to kick off if there's something in particular?
I don't have a lot of context as to the work that was done on pulling the data to fit it to conviction voting for, I guess, the Aragon pilot. So I don't know if I'm the best person to start.
Okay, yeah, great. So, right, that was Sem, Andrew, and myself and Z were kind of facilitating that to get the data basically out of the, right, so context. The Aragon conviction funding experiment, we pulled some data from that experiment and kind of did the data munging required to put it into the cadCAD model. So Sem was on the Aragon side of that, so basically pulling all of the data from the chain, and then there were several kind of passes to clean up the data to be able to feed it into cadCAD in an understandable format. So yeah, maybe Sem, if you want to weigh in on kind of your side of that data process, then.
It's amazing.
Yeah,
This
sure.
was one of the worst candidates.
Sorry, what
no problem.
it was to get the data directly from the Web3 API, and it was using a script that me and Luke wanted to use in order to return the gas fees to the people who were voting on the conviction voting contract on mainnet. So because we reused it, it was not the most efficient way to get that data, but it was enough in order to get who was interacting with the contract, mainly who were adding proposals, who were staking conviction on proposals, and who were removing and maybe canceling. Those were the four actions that people could do, and we were able to get the parameters, how much they were putting in, and that stuff. Later, I will be sharing another way that we can get data from the conviction voting application using the graph, which is a different way, and it can give us much more flexibility in order to get that data. But for this first thing, what we used was a script that is in the conviction voting repo itself under the scripts directory, and it can be used for any conviction voting application. Also, if we wanted to use it for OneHive or whatever, we could get all the it is getting all the transactions that are happening in a conviction voting app, and it processes them. So that's my part. What we did was get that data and put in a CSV, and then Andrew and people at Block.Science made that analysis, but I don't have any more details from that part, so I will let you explain us.
Yeah, so that was the main thing that we were going to have Andrew talk. Oh, is Andrew here?
He's just navigating the Discord. I'm chatting with him in Slack. He should be here any second.
Cool. Yeah, so I guess the context is that Andrew Clark, who worked on the conviction voting models with me, actually was doing some analysis with the data through collaboration with SEM, and that one of the goals here is to sort of, well, really, that was part of the original goal with that project, was to kind of get that figured out so that we could do it with the OneHive data, because OneHive is ongoing, and that was just one pilot experiment for Aragon. And so the ability to pull and feed data from real life, basically from the contracts themselves and people's behavior, into the cadCAD models is one of the main goals of the cadCAD as digital twin, cadCAD as computer-aided governance approaches. And so OneHive has continued to be kind of vanguard on that stuff. And so we wanted to kind of get down to brass tacks and look at how to get the real data from the voting system into the models to provide sort of visibility, decision making, et cetera, and continue to hack forward on basically what we could do from a data science context with those things combined.
Cool. So we have Andrew with us now. So I guess we are recording. So the first few minutes of Sem stuff. Sorry, Sem, I wasn't able to listen with full attention because I was chatting on Slack at the same time. But basically, what we're looking to do here is convey the information and the experience gained in bringing the live data from the Aragon conviction funding pilot into a cadCAD model. And we're looking to do basically similar for the OneHive ecosystem and feeding live OneHive data into the existing OneHive cadCAD model. So Sem gave us a bit of update from his end on how he pulled the data from the chain. And maybe Andrew, if you have any tidbits from your end over where we fit this data into the existing conviction voting model, or any tips for the modelers working on the OneHive version of this model?
Sure. Yeah, I can walk through how I adapted that on based on the Aragon data. I can walk through like the cadCAD code and kind of show how we pull out the behaviors. The main part is pulling out the behaviors and adapting to them to basically read in at each time step. So I'll share my screen and walk through kind of what I did there, and it's very similar because the Aragon implementation is pretty close to OneHive, and then it'll be more evident, and then you can see how to fork the OneHive code and adapt it. So let's see here. I will be sharing my screen, and then you should be able to see Aragon conviction voting pilot data. Did everyone see my screen?
Yep.
Yes? Okay. Perfect. So I'll walk through kind of like how I got the data and what did I do to modify it, and then kind of like clean up the data. It depends on how you get it from the chain data, and then show how I saved it, and then how we integrate that into the model and be able to run it off of the live data. Let's see. Hopefully this GitHub version will work. If not, I'll have to pull up a local. It's the problem about if it's a public GitHub repo, you can use the NB viewer. Let's see. I might have to do something here. I don't know why. This is only 54 kilobytes. Not usually a size we need to be concerned about. me pull up the data here.
In the meantime, I'm also looking for the script that we were using. So we have the entire thing.
Okay, so here's the here I'll just walk through based off a local copy. It's on GitHub, but basically what we have is pulling in a dump of data. So in this case, we had transaction hash, block number from gas used, what the function was, like staked proposal, withdraw from proposal, and then some parameters, which will depend on which function you're using. So basically get this data, clean it, take out some of the unknowns, fill in A's, normal data science things. By getting from the timestamp, able to get from the block number, is able to get the timestamp, and then it can combine that with ant, which is the relevant currency there, and add that into the data set, which we'll use in the model. We also have to create some unique proposal IDs, and then based on which function it was, clean up what the specific parameters meant. Was it amount? And we had to calculate if it was we or what type of yes. Okay. Well, I cleaned all the data and got it to where it needed to be, so we didn't have any issues with moving to a cadCAD model, and then saved that for use in building the model. So essentially, what I did, I'll walk through this notebook, and then I'll walk through the specific code. Is you can import the data from CSV to cadCAD. I'm kind of showing the function that I have here. Is first we do an action decoder, which is takes in, we add a state of the row, the individual row of data. We read that in, we increment that. It's a state that says we're at row 1, row 2, row 3, row 4 of the data, and that's going to be each time step of the system. And you can line that up with block number or the actual timestamp. And then, depending on what function you're using, is this add proposal? Is this stake to proposal? Is this withdraw from proposal, execute or cancel? In this Aragon implementation, it will be different in the OneHive. Then we can create an action. And then based on that action, we will then update what happens. I'll walk through those specifically. But when you run that, you get the same data. You can get the same plots as you did when you were running the full behaviors, which is the simulated information, which is what OneHive has right now. But we can pull that out and then replace it with real data, which is really cool, which is what we're showing here. So I'll dig into the code exactly and show what I mean and how that happens. We also have Block.Science has an I can share a link in this channel after I'm done here. We have a Uniswap example that is also reading in live data. And is an open source example that I can share that will help with this adaptation, because it's hard. The hardest thing is getting the data in the right spot and identifying what are the specific actions that you need to take. So assuming some familiarity with the OneHive implementation, I'm going to just show here of we've basically taken, there's so many behaviors, adding proposals, adding participants, all those staking, all those sorts of things that we have in a OneHive model. Those all go away because we're reading off of the data. And essentially, the network really simplifies down into having a policy, which is essentially an action decoder, and then we update the relevant states as a result of that, with the addition of a row and a block number. So what I have here, and all that behavior logic is where most of the complexity is, and that goes away. So we read in a CSV data set, as we can see here. The action decoder takes in, I showed a little bit of that, how that worked already. I can go back, and I open up in a minute for questions. I can go back and show how specifically works, but we cleaned all the data. What do each of these functions mean? And then we create, what are the actions? And I'll go show you what each of these actions means. And then we pass those into the network that depends on what the action was. If it was in type add proposal, well, we have to add another node for proposal. We have to define what those are. What's the funds requested? What's the trigger? If that participant doesn't exist, we need to add a participant. If it does exist, we need to add the edge, adjust the edge weight, and all of those different things. So we're updating the network. So this logic can get complicated to make sure you update exactly what it is. But we've taken all the behavior out. It's just accounting functions now, essentially, in the network, because all the complexity of what's going to happen is removed. But all the plotting and things like that stay the same, as we're using the same network architecture. So basically how I had the different functions, the actions, if we look here, is pass if I see, is this what we're seeing in the function column of our CSV? If so, add proposal is the event. So we put the event in here, and this is what the action that returns out of that. So basically, the action is add proposal. It's a dictionary we're using. Effective supply delta is a 0 in this case. Funds is a delta. Participant delta, we get the unique ID of the participant, so we can check if they exist or not, and that's what we use in that behavior. We check what are the participant holdings. In this case, we didn't have that data. What you have in the OneHive implementation, you may have that data. Proposal delta, well, that's what this proposal ID is because we're adding a proposal, so there is a delta here. And then requested amount, what is that specifically? And we can have those actions I like to keep consistent with just the change of the type. And then like it would be a negative if we're canceling a proposal on proposal delta and things like that. So, and then we still use the trigger threshold and those sorts of calculations that we had. But we take away all of that in-depth behavior policy and just essentially read in the data with some accounting functions. So I'll pause there right now. And I can go back to specific sections. I just wanted to quickly get through and give a high-level overview of kind of what's going on here. And I know it's kind of confusing, so we can dig into specifics.
So, Andrew, I'll just I kind of want to say what my understanding is of what you've done here, see if it's accurate. So essentially, I think there was a model, a cadCAD model for conviction voting that was sort of probabilistic based on user policy functions to simulate how conviction voting is gonna unfold and what's gonna happen. And then what you've done here is you've taken that architecture, that like infrastructure, and you've taken real world data, so you've replaced all of those policy functions with actually observing the real world data and sort of just switching, outputting the action that matches the reality that happened. So this is sort of repurposing like a simulation, a probabilistic model onto real world data to have the same sort of like stepwise not like it's like moving from a simulator into a sort of reality reliving machine. Is that accurate at all, or?
Yeah, that was a very, very good summary. Great job with that. Yeah, so essentially we're moving from a simulator to that. We're still in that notion of this is a digital twin, right? Initially, we're just simulating what that is. Now it's like a decision support system where we're actually getting that data. And you could see an extension of this is, okay, this is great. What's OneHive going to look like in a year from now? Well, then we can add, systems identification type forecasting functions and stuff onto it. But you did a great summary of, we took all the logic out and we now added real world data. We can still use the same cadCAD software, but then like the opportunity of what you can do, it will change and become more powerful now that we're using real data.
That's really cool.
Thanks. Yeah, I think OneHive with the amount of data, and you guys have way more data than what I had here. So you're going to be able to get some really cool simulations and be able to make some really interesting decision support software off of it. Is there anything? It sounds like you have an awesome understanding of what we just of what we did. Is there anything you'd like to go deeper on, or any other questions you think would be helpful for the group?
So I know that Sem has put some code together for querying conviction voting data from the graph, and I've actually he made a really nice Python snippet that I took last night and sort of ran with it and queried some data. So I have a small data set that we can just take a look at, and what you're doing, it's really actually inspiring because I think Sem gave an example of how to just pull like proposals, but I wasn't even thinking about all these actions that are available, which would then of course fit the cadCAD modeling. I was doing just some like exploratory data analysis, like how much honey has been passed for proposals and what user has been involved with the most proposals. But this is such a more granular level approach than I was thinking. So it's cool to sort of bridge these two ways of thinking. One, just querying the data, but then secondly, this granular level of actually like plugging into the cadCAD modeling at an action based level. So I'm wondering if Sem wants to touch on his query code, and then I can show how I've used it.
I can proceed from here because I think that it's a natural a natural evolving, because I can show the script that is needed in order to get the data to fill up the cadCAD simulation. And it is here in conviction voting app in the scripts folder. And basically it can be used very easily. It's a truffle script. Do you see my screen well enough, or
Yep.
I can? Okay. And the idea is that you tell the script which network you are using. So probably it's going to be XDAI. Well, actually, in the Aragon pilot it was mainnet, but in our case it will be XDAI. And then you have to put here the address of the conviction voting application. This is not something that is popping out, but if you inspect the code of the honeypot, you can get it quite quickly, or at least you can get the address of the DAO, and then by going to the DAO, you get the address of of all the apps. And also you can get if it has a lot of transactions, then you can go from a certain block to another block. So it can be paginated and it doesn't fail. And I don't remember that expanded thing, that expanded flag was, but we will see. And if you don't do anything, there will be that default proxy, which probably was the Aragon pilot, and you have here the actions that you are going to look at. The thing is that it's using Web3, and it is a bit difficult to use. Instead of loading here an ABI with the code, I just call the contract directly and tell it what it should look like. So I am looking for these specific calls to the contract, and then, well, it go through all past logs and get the transactions, and this is why we get that CSV with all the transactions that we have. This is something that any DAO that uses conviction voting, at least the contracts that we have been using until now, and because most of them are using these codes. And I also wanted to show something else. But first of all, if you get that script and run it with the proxy application, the conviction voting application, you will be able to get the data in order to put in the model. Secondly, we have this.
So Sem, I just want to confirm. So that script there, is that the same script that was used to get the data for the modeling that Andrew was just going over?
Yes, exactly.
Okay, cool.
I send them the CSV and also share with them the code. But the thing is that it's very important to have exactly exactly what you said. Then the thing is that from that thing we only obtain the transactions that we have been all the people has been doing, but the current state is a bit more confusing to get from it. And in order to get some data or cool visualizations, what we can do is to query the data directly from the graph API. The graph, well, actually it's what we use for the frontends. It's a decentralized network that reads the data from the blockchain specifically the events and everything that happens, and it processes it in order to get a GraphQL API. So if that's specifically the one that we use right now in the One Hive DAO, it's called Honeypot XI, and the thing is that it mixes conviction voting with Dandelion voting, and it is the most updated version. But previously we used another one that it's called something like Aragon conviction voting XI, which is still used for the Commons Stack conviction voting application and for the tech conviction voting. So if you want the data from those other conviction votings, then you have to go to the other one. But in order to get the data from, and also previous, because this is the most recent one, if you want to see the data of the conviction voting proposals from August or September, you won't find them here. This is the most recent. Like when we began to use Honeypot version 2, in which the interface changed, this is the data from there. I think it's just 4 months ago. So what we can do with that? Here we can request the GraphQL with the things with this language in which you say, okay, I would like from all the configs, well, from the first 5 configs, I would like to know the ID and the conviction, and also voting. And in the configuration voting and in the conviction configs, I would also like to know which is the decay, which is the alpha. Maybe we can simplify it a little bit. And I just want to know, let's say, I just want to know the from the first five applications, I want to know which is the parameters that conviction voting uses. So if I run that, I will see that there is only one DAO, and that DAO has a decay of 0.99999. And this is the alpha that is used in the conviction voting. We also have a 10% beta, which means you cannot request more than the 10% of the funds. Actually, it's less. But we to simplify that, we say that it's the maximum 10%. And also we have that weight, that it's another of the parameters. And we can go much deeper into that, but in order to go deeper, we might need another front end for that, which I share it here. That legacy GraphQL bin, if you go here and you put as an API endpoint the Honeypot XDAI, you obtain that other front end in which you can send query variables. I could not find it in the dgraph front end, so maybe it's there, but I could not find it. The idea is that you can do queries that has parameters, for example, how much proposals you want to get, how much the pagination, the types that you want. There are 3 types. One type is the suggestion. The suggestion is about signaling with conviction. Then we have the funding proposal, And then we have the decision, which is a dandelion voting proposal. And the statuses can be open or closed or cancelled. We also have some metadata, whatever. There are many things that we can query with these variables. So, for example, if we want only commission voting proposals that are open, 0 is open in that case. I think that 1 is cancelled and 2 is executed. And I don't want to request for any metadata, but if I wanted to get, for example, I want to know the bus swarm, which are the proposals. When you look for in the search box for something, you are using that parameter here, the metadata, and this is why we are using this interface, because it allows us to add variables here. And now, once we have these variables here, we can use them in the actual query. So we are filtering by those parameters, and what we are getting is the ID of the proposal, the number, the creator, the status, the when it was created, the title, everything. If you want, we can run it, and we will see. It is going to grab the first 100 proposals, and it is going to take a little bit. Maybe I had to put there a 10. Okay. So for example, the first one is the abstain proposal. Maybe what we can do is to clean it a little bit, so we don't request so much things, because for example, in order to get all the stakes that one proposal has had, that is all the supporters that one proposal, how much they staked and all that. Maybe this is what is taking so much resources. So that's the cool thing of GraphQL, that you can query exactly what you need for, and if you only need the titles, you can just query the titles. Let's query just the titles. For example, take history out. And stakes out. Now it's still going a little bit slow. I think that my computer is not responding so well. But if we go just with the metadata, we will see all the titles, and we can request, for example, only numbers and metadata. So we have them ordered, all the proposals. They're open, because we are asking here for the ones that are open. But if we want to, if we don't want to filter only for the ones that are open, well, we can put all kind of statuses, and we will see all of them, 1, 2, 3, 4. And if we want to show the status, we should be able to get it. The abstain proposal is active, the particle farm is active, the XDAI faucet is executed. And basically what you can do with the GraphQL is to create your own query. Now, once we have been playing with it, of course, it is going to offer you the latest state of it, and it might or might not contain historical data. The difference with what we had in the script is that it gets all the transactions, but not the state, the current state. You can create you can replicate the current state based on the transactions. But in that case, I think that you can get all the transactions kind of. I'm not sure with the stakes. You can ask how much stakes something have, or you have a parameter that it's called stakes history. I I have it, but I think yeah, stakes history. And for each one of the stakes, you can know how much tokens were staked, which was the time in which it was staked. So basically, this part replicates when people is staking or withdrawing their tokens from a proposal.
Hey Sam, can you talk? This might be exactly what I'm asking for, what you're showing here, but I'm wondering, can you show the bridge towards like what Andrew had where he was mapping the actions? How do we get those actions? Is that exactly what you're doing here with the stake history?
No, the thing is that most that that has been processed
Mm-hmm.
from the initial actions. In that GraphQL is data that has already been processed,
Mm.
and the initial actions, if they are available, is because in the process they were added in some way. For example, I guess that, but it's much more difficult. I mean, if we want to go with the in the path of the having which were the actions, probably it's better to go with a script like that requests all the transactions that happened in a particular smart contract,
Mm-hmm.
or do something like this.
Okay, so since we already have that script that gets exactly that data, then that's fine, right? If we wanted to reuse the work that Andrew has done with the digital twin there, we can actually just run that script and get that type of data.
Yeah. Well, what I wanted to say is that in order to get some cool graphs on which is the current state of the, for example, which were the right now, how much active proposals do we have versus how much closed proposals or cancelled proposals do we have. This kind of data,
Mm-hmm.
the current state data, can be gotten from here, as I was showing with the statuses and everything. And in order to do the models with cadCAD, probably that's a better source,
Mm-hmm.
this script, because it gets all the transactions in the blockchain. That's
Awesome.
that's where I will do the difference. Yeah.
Yeah. Yeah, that makes a lot of sense.
And
I can. I'll let you. I'll keep going, Sam. I want to see everything you have to say, but I can. So I've played with this a little bit. Some of those cool graphs you're talking about. I, I might have some
I would
genius.
love to, yeah, I would love to see what you get. And also, if you want, we to proceed with that, what we can do in another moment is to run this script with the one hive data. I think that right now it doesn't have so much sense because I want to see what you were doing, but it is very easy to run, and we can proceed from there.
Okay, awesome. Can you post this link here and also, yeah, just is this link available or maybe just post it in Lunaswarm channel?
Yes. Yes, totally. Do you want to share your screen?
Sure.
Easy.
Okay, so one thing. So I've started a Notion doc to organize some of these links, but I didn't grab. Did I? I know I posted it in the lab earlier, so I have this link to Sem's work. I'm just gonna copy. Oh, yeah, here. And so let's take a look at this, because Sem actually, he didn't, I don't think he finished going through all this, but the last piece is he actually put this all into Python. So everything he was doing right there on directly in the browser, um, you can plug those same queries and query variables right into Python to get that data. And so I've taken this, I plopped it into a Jupyter notebook, and let's see. So what we get here is this result. So it runs the query, it returns this result, which is a JSON object or a dictionary at this point. So we index into the data, and there's only, if we check the keys here, there's only one key. I guess that's due to our query. So that's the proposals. So let's index into the proposals. Okay, so this is always what we want to get to when we're sort of pulling in data into the data science environment, because what we have here is a list of objects. And so whenever you see a list of objects, you should get super excited, because this means this can be transformed into a data frame nicely. So all we have to do is go pandas.dataframe, and we get this awesome data set. So this is so powerful, like combining this data frame environment with the abilities of GraphQL, because it's so easy to rapidly experiment, especially with what Sem linked with these front-end apps. You can just really hack on this stuff fast, try, querying all sorts of whatever you know about the smart contract, I guess, like any sort of aspect of it, and get the different attributes and metadata. And when you've got something you like, just plug that into your Python request and then create a data frame out of it. So here we have beneficiaries, the timestamp it was created, the creator, the ID of the proposal, a link. This is super cool. I love that the links to the forum posts are in here. We've got metadata, which is essentially the title, so that's nice. The proposal number up to 121. Requested amount and status. So now this is what you were mentioning, Sem. We can filter by status, and I think we could do that now. So let's just say take this data, and we could like group by status. I wonder if we could go like dot group by status, and then take what is it, like sum, and then take the total allocated, which, oh, the requested amount. Oops, what happened? I'm not sure. I just pushed a bunch of keys on my keyboard by accident. Amount. Oh, okay. These are strings, so they have to be converted to integers. So I'm gonna come back to that one. I don't want to spend too much time live coding because we're almost at the top of the hour. So I'll just show you what I did put together. Oh yeah, so here the first thing I do is I map those requested amounts actually to integers and divide them. Okay, so see if this works. Oops. Okay, so here we can see that there's 42,500 canceled, 1,800 has been executed, and there's just over 1,000 active. So we can start to get some pretty cool results like that. Here I just lay out, I group by beneficiary and separately I group by creator and sum up the requested amount. So we can start to see which IDs have received the most and have had the most pass through in proposals.
Who has been cancelled so much proposals? Do you know, Luke?
I don't know. I don't know who's canceled proposals, but
Okay.
anybody who like doesn't have success might cancel them.
That's a lot of proposals. I mean, most of the proposals get cancelled.
So is it possible that some of it is just like buggy interactions? Because if I remember that in the Aragon test, we did run into issues where, at least on the front end side, it seemed like proposals were duplicated and then the extra ones were canceled. I'm not sure how much of that actually made it through to the network or whether it was issues on the front end side, but it seems possible that some sort of duplication could result in people canceling things, even if that was early on.
Also, I mean, you're looking at the requested amount, so like that's not really going to tell you how many were canceled. You could have a single proposal that was like requesting an absurd amount, then they realized, oh, I can't really like actually ever pass this proposal.
Right.
So it could just be like one, right?
Right. Well, and to be clear, like what's so cool about this is it facilitates exploratory data analysis, and in practice, that's a really important part of understanding things long before you start funneling them into more advanced analytic apps or models, etc. Like this basic data sense making comes from having reasonably well structured data that you can explore the nuances of.
I thought that we were counting, not summing. That has much more sense now.
Oh yeah, we could just do a count. Is it this easy? Oh, okay, this is interesting. So 30 active, 63 canceled, and 28 executed.
You can do dot describes too. It'll give you a bunch of statistics.
Right. I think like
that should work. It's an aggregation method in pandas.
Yeah, I might. Let's see.
You might need to do it before. Oh.
I think either would work. Yeah, so we get the count, we get the mean, so that's super. Yeah, so the mean canceled is 675. Well, something doesn't seem right. What have I done here? Oh, these are all executed. Oh, I seem to have filtered. I'm doing two different things here, so I'm kind of getting this mixed up in my Jupyter notebook. But let me just refresh my data here and sort values by. Oh yeah, so there's one that requested 7,500. It was a test. Where's the metadata? Oh, it just says test, and it was canceled.
Somebody trying to request the entire common pool, I guess.
Oh yeah, there's a whole bunch. Look at this: 6,000, 6,500, 7,000, 7,500, all canceled.
Give me everything.
Yeah, give me everything.
It was a test, guys. I swear.
Yeah. That's hilarious. So, yeah, Zargum hit the nail on the head. I think this is really what I'm good at. This is what I am useful for, is the exploratory data analysis. This is where, yeah, and there's so much that can come out of this and can sort of inspire the models and can offer insights and information to tweak the models. So it's pretty interesting to go back and forth with this stuff. And what I finally got is a couple charts here. And for some reason, you see these labels are all mixed up. This charting library, hvplot, it takes this parameter rotation, ROT, which should rotate the labels. But for some reason, when I plug it in here, the whole chart just disappears. So that's a little bit frustrating. But
you can do it manually with matplotlib if you need to, but I wouldn't stress
right.
about it.
Now we get this hover functionality, so that makes up for it. So we can actually go explore what these are. So the largest, oh, and this is sequentially over time. So these two charts kind of correspond to the same x-axis. So here we just have cumulative honey over time that has gone towards executed proposals. And so you can see in November, mid-November, there was a big jump, pretty flat. And then early January, there was quite a bit. And then it's been quite flat since then as well. So this is pretty interesting to see.
Cool.
Yeah. And so this is sequentially, like chronologically, but this axis is not actually a time axis. It's labels. So although these are ordered in the same way, they're not exactly the same. So this giant one here might actually correspond to something over here. And that was, so the biggest executed proposal was the Honey Tollgate refund for 300.
Mm.
So this is pretty neat.
That makes sense.
Mhm.
Just a commentary from a real world validation perspective, right? Like part of the point of that exploratory data analysis would be to make sure that things make sense relative to experiences in the real world. So anyway, I think this is really cool. I'm going to shut up and let you keep talking.
Oh, thanks, Sargum. I really appreciate the comments. And so I think we've painted a really beautiful picture through what Andrew went through, what Sam went through, and what I've got here. We've got like this, I feel like we've got all ends of the spectrum. We've got this super granular level action-based digital twin. And then we've got, through SEM, we've got all these ways of pulling the data. And then here we've just got some example of how we can get super nice clean data through the GraphQL experience, and these insights can be used back into the modeling to inspire the sort of the direction that we go with the modeling. And like Zargum said, to just sanity checks, like just check that yeah, this data does make sense, it does match what we've experienced going through this. Now, I think I just have some visualization work that I've done as well. So I essentially took the work that Luke had, and I just output the data set at the end, the results, and then I started in a new, I think I'm just going to jump to the end here since we are, I didn't import my dependencies. Okay. Okay. Sorry, this is super messy. But if I get to the end, you'll see the point. Does anyone have a hard stop?
I can roll over a little bit. Honestly, I think I scheduled or suggested this time because it's one of the only times I can actually roll over.
I've got a little bit more time too.
Okay, cool. So I've left these sort of sketch notes here so that people can go see what process I went through. So essentially I load up the data. So this is the data as we have it, as we left off last week. Simulations, runs, the parameters, and etc. So first of all, I just printed the columns to understand what we're working with here. And then I started using HoloViews, and what HoloViews does is it lets you it lets you visualize a dictionary. So, and what that is you're going to have keys that map to visualizations. So essentially here we get this widget that allows us to select our key, and I just made all of the columns of our data set the keys. So we can select for a column like outflow rate, and then what we're going to visualize is we're going to select that column from our data frame and plot a line of it, but we're actually going to get all the lines of all the runs. So this gives us an idea of, for each thing that we're modeling or each parameter that we put into our system, we can see the entire sort of bounds of what it's done over all runs, over all simulations. So this doesn't really help us like differentiate what different system parameters are going to do, but it does just paint a picture of how different variables are going to play out, and it can actually help us just understand what's happening too. Like if we plug in, should be, if we look at, some of these are kind of weird. What was it, like run? Okay. Okay, these, some of this is just totally confusing, and I did this at like 3 in the morning last night. But it's a nice thing to play around with. It can give you, like, here's market cap, for example. Was one simulation where it looks like market cap just went straight down, or we might get some weird artifacts here with these straight lines. Actually, now that I'm thinking, if that could be a bit of a glitch. But let's not get too stuck on that. It's just sort of an introduction.
I think I know what that does that. So when you, with some of these tools, it connects back to the origin when it has multiple. So what you have is a bunch of lines from the place it ended back to the starting point.
Yeah.
And so there's a overlay. And it's not that bad. Like, I'm pretty sure you can clean it up.
Yeah, I think that's exactly what it is. Yeah. So then I thought, okay, how do we sort of isolate these and look at one at a time? So I just took a single simulation, and we're looking at the price here. So okay, we get all the prices of a single simulation. Now, what did I do here? So this is just a scatter plot. So now, oh, this is the same thing that I had before, just looking at scatter plots and alpha channels. But here we actually take the mean over all runs. So now we're getting something interesting. So now we're grouping here by simulation. And so same thing as before, we can select for what we want to observe. But it would be nice if we could actually see all of these at once. So I wanted to move into this like grid spec. So all I do is expand. Instead of having a widget here, I visualize all these at the same time by making this, it's called an ND layout. You just use this ND layout and you get this result. And then, let's see. Params, what's params equals params.keys df.setIndex. Params.keys, what was params? There's a nice big finish at the end here. I got actually quite a nice visualization. Trying to remember what really what is this params? I can post this. So basically what we get next is what you see here. I combine these, so we have a grid layout, and then I also lay out a selection widget, so you can kind of look at everything that's happened, and then you can also zoom in on any one of them. But in addition, I lay out a table of the simulations, and for each simulation, I just show what parameters were ran for that simulation, so that you can get an idea of, like, you can compare each simulation against each other. And then I also lay out a table that has just the 4 simulations, and for each simulation all the parameters that go along with it. So that's probably what I was doing here. Unfortunately, I did this at 3 a.m. and last night. I thought it was working perfectly when I pushed it, but luckily I was recording myself coding, so I could jump back and check out what this was. I think I accidentally deleted a very vital cell, and I can push this upstream. I kind of wanted to show it off before pushing it to get some feedback and just think about where to go next with this. I think what I'll do, since I got a pretty good output here, I'll just make this clean. I'll make a nice, really clean notebook that gets towards this sort of output and push that.
That'd be awesome. I really want to play around with this a little bit.
That makes sense. I also, so some thoughts, just because I know we're short on time and my phone might die. What you're doing here is very much data that I sort of envisaged as the, like, leading into something like the quote unquote Commons Analytics Board, which is something that we had specified as part of this broader, like, vision for a DAO. And I think one thing that I would point out about this is that, like, on one hand, you've got the UIs that you use for searching through proposals, making proposals, voting on proposals, which are very much tactile, therefore doing stuff, not seeing how things are going. And so I sort of, some synthesis of the things that were being explored here to me would manifest as the MVP dashboard for OneHive. And I think of it a bit like the difference between looking at the UI for HoneySwap, swap, or add liquidity versus the UI when you click through see analytics. And honestly, although it's a little bit tricky, you got to know that it's over there. Once you get into it, it's really nice and it's cool to understand the state of the system and how it's evolving in time and what people have been up to. This is essentially the starting point for being able to do that, not just for the economic functionality, LPs and traders, but actually for governance functionality, proposers, voters, etc., and start to give some visibility into the impact of your choices, potentially about what you're spending on and, which proposals are recurring and which ones are one-offs. And you can think of a lot of things, but just hold in your mind this idea that as governance participants in OneHive and like contributors and builders and whatnot, the state of the system isn't just the state of the HoneySwap contracts, and it's not just the current outstanding proposals that are in flight, but actually like historical information about the frequency with which things pass as a function of their size, what's recurring and what's one-off, and any number of other things that are more related to the data that you're exploring and that are generally, at least in my opinion, interpretable as manifestations in real life of the things that were modeled in the design. So that's like a props, but it's also like a kind of a call to action for this group. Like if we start to be able to understand what that might look like, to me, that's a really natural consequence of this work would be to eventually submit a proposal that was for some sort of, analytics for OneHive, even if it's MVP, to get it sort of built and pushed to provide that same level of visibility to the governance activities that we've already pushed for the economic activities.
Yeah, I think that definitely makes sense. Exciting stuff ahead.
Yeah, that's really cool. This iterative approach where we all combine our skills and work towards this dashboard kind of output. Sounds pretty awesome.
Yeah, I mean, like, I'm saying this as a honey holder who's going to vote for stuff and voting to give honey to do this. So I'm actually like really Taoist in the sense that I really love it when we prove that we can just do some research, come up with some ideas, throw it all in a pot, mix it around, make a proposal, fund it with our own freaking organization, build it and deliver it. And people are like, wait, who funded that? And we're like, we did. Which is basically the productivity metric in Luke's model, right? Like, what did you do? Well, we turned honey into stuff. How did you do that? Honey isn't a thing. Well, honey is a thing because we turned it into stuff.
Yeah. Cool, guys. So I'm gonna clean up this notebook and I'll push it in not too long today.
Awesome. I'm gonna hop off because I've got a check-in call with the hackathon team, but I'll catch you guys later.
Well, thanks for joining us, and I'll see you next week.
Sounds good.
Bye.
Great session. Thanks, guys.
Thanks, everyone. See you next week.
See you next week.
Bye-bye.